Why are deep learning epochs and batch size crucial? Imagine training a robot to recognize your face or translate languages. How well it learns depends a lot on two key settings, epochs and batch size. These are like the gears that control how a deep learning model gets smarter. If you set them just right, your model learns efficiently and performs better. If not, it might struggle or even get confused. An epoch is one complete pass through all the data you give the model. Think of it as a full review of a textbook. When the model finishes one epoch, it has seen every example in your dataset once. Usually, you need many epochs so the model can fine-tune its understanding. But if you use too few, it might not learn enough and perform poorly on new data. This is called underfitting. On the other hand, if you use too many epochs, the model might memorize the training data too closely. This is known as overfitting, and it can make the model bad at handling new, unseen data. So, choosing the right number of epochs helps the model learn well without memorizing everything. Batch size is about how many data points the model looks at before updating itself. Instead of feeding all the data at once, you split it into smaller groups called batches. For example, if your batch size is 50, the model looks at 50 examples, learns from them, then moves on to the next 50. Smaller batch sizes mean the model updates more often, which can help it catch subtle patterns. But it might also make training slower and noisier because each update is based on fewer examples. Larger batch sizes give smoother updates and can speed up training. However, they need more computer memory and might make the model less flexible in learning small details. Both epochs and batch size work together to shape how your model learns. More epochs mean more chances for the model to improve, while batch size controls how much data it processes at once. If the batch size is too small, training can be slow, but the model might learn more detailed features. If it's too large, training speeds up, but the model might miss some finer points. Choosing the right combination depends on what you are training, how big your dataset is, and what kind of computer you have. For image recognition tasks, you might use larger batch sizes to speed things up. For natural language processing, smaller batch sizes can help the model learn better. Also, the number of epochs should be enough for the model to learn but not so many that it starts to memorize. In the end, epochs and batch size are like the recipe for training a good deep learning model. They control how fast and how well your model learns from data. Getting these settings right makes a big difference in how accurate and reliable your artificial intelligence systems become.